Hello guys, my name is Balkrishna Shivastav and welcome to Code with BK. So in this video, we learn about what are pointers in C programming. So before we begin, it is a request to please subscribe to my channel. So we learn about pointers in C programming in this video, and this topic is, I guess, difficult for a lot of people. Although there is not much to this, but I do feel that there is a kind of deep understanding related to this. So if your concepts are not clear, there are chances you might get confused and you might not understand things very clearly. Okay, so I'll try to cover things from the basics. We'll start from the very zero, very scratch, and we'll try to build upon it. Okay, so we start with what are pointers, what is dereferencing a pointer, what do I mean by references, address. Then we look at arrays as pointers. Then we look at pointer of a pointer. What are null pointers? What is a dangling pointer? If we find time in this video, we look at function pointers as well. Else we cover that later in a separate video. Okay, so first is what are pointers. Okay, so think of pointers as a variable with a name. And what do I mean by this is, suppose if I have int p equal to 10, okay, or I'll say int a equal to 10. Okay, so this is very clear and very intuitive that you have a variable with the name a that is of type int, that is, it is capable of holding an integer value and is currently holding 10. Okay, if I declare an integer pointer, and how do we declare an integer pointer? We say int, we use a asterisk symbol, we give this a variable name, any name, okay, any valid identifier name, and we say this is integer pointer p stores the address where a is stored. Okay, so this is how you declare a pointer, and a pointer can be an int pointer, a void pointer, a double pointer, a float pointer, a pointer to a struct. Okay, right, just as we have integers, floats, doubles. Okay, we can have corresponding pointers as well. Okay, now let me explain what happens behind the scenes in the memory. So for example, if this is your memory, right, okay, where your variables are assigned memory, we have int a equal to 10. So there is one block of memory picked up. The name of this memory is a because the variable name is a, and it is part of this main function. Okay, you set the value 10 here. Okay, so a memory block for 4 bytes that can hold an integer is given a variable name a. Okay, when you do the second line, p ampersand a, think again in terms of a variable with a value. Just as a has the value 10, pointer p has the address where a is stored. Okay, pointers store addresses. Okay, pointers store addresses. Okay, now what do I mean by address? Because so this is memory, all memory locations have an address. Okay, this is something that you have to assume and understand. All right, all memory locations have an address. So this line means this variable p is holding the address where a is stored. Okay, so when this happens, you get another memory location because pointer is also a variable with a value. The name of this variable is p, right, lowercase p, that has some value, say addr1. Okay, it's a hexadecimal value because the memory locations are all hexadecimal values. Okay, so this value a is stored at this addr1 address. Okay, and this variable p that has a memory to store an address is storing at the address where this 10 is stored. Okay, so addr1 is memory address. Okay, memory address where a is stored. Okay, so I'm going to use the terms memory location, okay, a location in the memory, okay, address of a location. Okay, these two, okay, are synonymous. Okay, memory location has an address, and we say that address of a location because all memory locations will be having an address. Okay, and I will also use the term reference. Okay, so reference is nothing but address of a location. Okay, so we say p, okay, stores the reference to a, that is, it is the storing the address where a is stored. Okay, all right, trying to understand these two lines. When you say a equal to 10, that's very clear. It gets a memory location that can hold an integer 10, 4 bytes, and the name of the memory location is a. When you say this, you are saying I'm creating another variable p. Just as you create a variable a, you create a variable p. What type of variable this is? It is an integer pointer. Just as we can have int, float, double, we can have and structs, we can have corresponding pointers. We have int pointer, double pointer, float pointer. Just storing the address where this particular integer is stored. So p is a variable that has a value, and the value is the address of where a is stored. Okay, so pointer store addresses. Okay, pointers are also variables that hold a value, and the value they hold is the address of a memory location. So the variable p is storing a value addr1. addr1 is the address where a is stored. Okay, so we say p is a pointer to a. Okay, so this phrase stores the reference to a, that is stores the memory address of a, memory location of a, or we also say p is a pointer to a. Okay, so we use this synonymously. P stores the reference to a, that is the location where a is stored, or we also say p is the pointer to a. Okay, now what do I mean by this is, so if I want to say print the value of a, the first thing we can do is printf a equal to %d \n and a. Okay, simply prints the value of a. So gcc pointers.c/pointers. Okay, a is 10. Then print the value of a using the pointer. Okay, so we say a is, okay, we use dereference the pointer. Okay, that's why I said reference means storing the location where a is. Okay, reference is address of a, dereferencing is getting whatever there is at the address of a, which is the value what a is storing. Okay, so how do you dereference? You use star again, and I understand this can be confusing, that in order to declare a pointer you are using a star, in order to dereference also you are using a star, but that is how it goes. Okay, so when you want to declare an integer pointer, you say int type and star, and you say the variable name. Okay, when you want to dereference, you say star and then you say p again. Okay, so this means you are dereferencing p, that is you are getting the value which is stored at the address what p is storing. So dereference, okay, give me the value stored at this address. Okay, so p is storing an address, and dereferencing p means give me the value at this address. Okay, so p stores the address of a, and a has 10, so you get 10. Okay, so when I compile this again and run this again, you see I get 10. Okay, now how can we prove this is, since we have the address of where a is, we can change the value stored in a without using the variable a. That is, if I want to change the value of a, I can say equal to 20. Okay, and if I print again, okay, right, I get a equal to 10 first, and then I get a equal to 20. Okay, all right, but what if I don't want to change the value like this? I can say, so when I say a equal to 20, the compiler knows, okay, the memory location where a is this, and you change this to 20. Okay, okay, one way. Now since p is storing the address of where the variable a is stored, I can say change the value which is pointed to by p, that is where the variable a is stored, to 20. Okay, and again we are dereferencing like this. Okay, and I can understand that this is confusing, because if we want to get the value at this address which p is storing, we do this. If we want to change the value at the address which p is storing, we do this. But this is how it goes. Okay, so when I say asterisk p equal to 20, it means p, whichever address p is storing, set the value of that memory address to 20. So now a becomes 20. Okay, so when I say compile and run again, okay, so a is 20 now. So even though we are not doing this, we are doing this. Okay, so this is what in very short a pointer is. Okay, just as a variable of type int can store the value 10, a variable of type int pointer, you just have to add an asterisk in front of int to make it an int pointer, can store the address of where an integer is stored. In this case, it is storing the address of a. Okay, now if I say int b equal to say 30, so when you do this, you get another memory location b, okay, which is a part of this main function, has the value 30. Okay, p was storing the address of a, so you can say it p is a pointer to p. Okay, then I say pointer p is now storing the address of b. So if address of B is ADDR2, so ADDR2 is address of B. Okay, so these are hexadecimal values. I'll show them. I'll print them in a moment, and you'll see these are hexadecimal values. Address of a memory location is a hexadecimal value. Okay, so when I do this, then I say the value in P is now the address of B. So this is ADDR2 now. ADDR2, because ADDR2 is that memory address or address of memory location. Okay, so it is no more pointing to A, it is now pointing to B. That is what we say. So P was initially pointing to A and now it is pointing to B. So when I print the value, dereference the pointer, get the value which this at the address that this pointer stores, I get value at the address that P stores. So I'm gonna print it like this, that P stores. Okay, so and I'm going to do this, comment this out. Okay, so first it stores the value at A, which is 10. Okay, then we change the value of A, which becomes 20, and then we set P as the address of B. Okay, so clear. Okay, now this is 30, right? Because P is storing the address of B, right? So we saw how to declare a pointer. Ampersand gives the address, and if you are C++ students, this is used for CPP reference as well, which is a different concept, a little different concept. Don't get confused. Okay, so this is used to get the address of A, where A is stored. Okay, then this is how you dereference. Then you can also do this to change the value of the address that P stores. Okay, whatever value the address is storing. Okay, the memory location store, you can change that. Okay, all right. Now just as you can do A equal to B, so the value of B is copied into the value of A. So the value of A is now value of B, so which is now 30. So the last output should be 30. Okay, just in that case you can copy pointers too. You can say int P2. Okay, and it is pointing at P. When you do this, what is happening is you say another variable, name of the variable is P2, it is part of the main function. Okay, the value it is storing is P, it is an integer pointer. So the address which P is storing gets copied to P2. So now P2 points to where P is pointing. That is how we say. Okay, so P is storing ADDR2, so P2 also stores ADDR2. So ADDR2 is the address of B, so P2 also points to B. Okay, so if I print value at the address that P2 stores is the value at B. Okay, P2. Okay, P2, what did we change the value of B? No, B is 30, right? B is 30. Let me just print B as it is. B as it is, so that we have an idea. Okay. Okay, clear, compile. Okay, B is 30 and P2 also stores 30. Okay, now if I change the value stored at address stored in P. Okay, so P is pointing to B, right? Okay, and I say change the value, okay, at the address which P is storing to, say 50. Okay, so you are saying change the value which P is pointing to 50. So value at P2 is also 50 now, value of B is also 50 now. So B is 50, okay, because the name of this memory location was B, and we have another pointer P2 that points to B, okay, which will also give us 50. Okay, all right. So if you start thinking of pointers in terms of a variable with a value, and the value that stores is not our integer primitive values, it is a memory address. Okay, and it can be a memory address of any type of a primitive value. So this is int pointer storing an address to an integer value. Okay, so we can have a float or a double pointer as well. For example, if we say a double pointer, so if I say double, D1 is 3.14. When you do this, you get another memory location, okay, that stores the value 3.14. The name of this memory location is D1 and it's a part of main function. Okay, so to store the address of this variable, okay, you need a double pointer. We say double, Okay, the type, then star, and name of a double pointer variable, we'll say p3, which is storing the address of d1. Okay, so the printing the value of d1, okay, and storing print the value of the address p3, right? So we get 3.14 percent lf. Okay, long float is basically your format specifier for double. So we get 3.14. By default you have 6 decimal places. You can fix this by doing %.2lf prints to 2 decimal places. Okay, so d1 is 3.14. Again, if I change the value, okay, which is stored at the address that p3 is storing to say 3.14, 2.67. okay, so now d1 will change because we had a variable p3. Okay, when I did p3, so this is p3 storing addr3, which is pointing to this, and I'll say addr3, okay, address or memory address of d1. Okay, and when you say this, you're saying the value that p3 points to, okay, changes to 2.67. so d1 also changes to 2.67. okay, so the second output will be 2.67. okay, so this is how your basically pointers work. Okay, and you can again have another pointer d2 that can point to d1. okay, and if you change d2, the value at where d1 is pointing to also changes. Okay, so remember the terms that I use. A pointer to a means a p is a pointer to a. It means p is storing the address where a is stored. Okay, the value that p stores is memory address of a. Okay, then I will use the word memory location, address of a location synonymously. Okay, it means the same thing. When I say memory location, address of location, I refer to that memory address where this value, where a particular value is stored. Okay, then I will also use the word reference. When I say p is a pointer to a, I will also say p stores the reference to a. All right, and dereferencing is giving me the value which is stored at this particular location, at this memory address. Okay, so I'll use the word address of a location or address / location synonymously. Okay, all right, so I will do one more concept before we move on to the next video, is pointer of a pointer. Okay, right, so just as pointers store the address where a value is stored, integer pointer is basically storing the value where storing the address where this integer value is stored. You can have you can store the address of where a pointer is stored. Okay, so pointer of a pointer is basically storing the address where a pointer is stored. Okay, so for if you want a pointer of a pointer, you need 2 stars. Okay, 1 star is for address, 2 star is for address. Okay, so if I say integer p4, it is storing the address of say p. Okay, when you do this, you are saying that give me the address of p and store it in the variable p4. And since p is a pointer already, you need 1 more star to store the pointer of a pointer, and the type has to be int because p is an integer pointer. Okay, so you want to store the address where p is stored, because p is also being stored in a memory location, right? It also has an address. So if I say I have another variable p4, which is a part of main, okay, stores addr4. Okay, the memory address of this location where p is stored is addr4. So p4 stores addr4. It means p4 is a pointer to p, a pointer to p. Okay, right, so addr4 is address of p. Okay, and since p is a pointer, you need 2 stars, pointer of a pointer. Okay, so let me just print the memory address values. Okay, so in order to print the address that a pointer stores, we can do printf. We have p, p2, p3 and p4. So p and p2 both point to this location, okay, where b is stored. So let's print %p and p. Okay, so p and p2 should have the same memory address values. Okay, so p and p2 should have the same memory address values. Clear. Okay, so P is this, and you can see P2 is exactly the same. Okay, and if you want to know the location mem address of B, because they are storing the memory address of B, you can say ampersand B. This will also give you the same value, proving what we are trying to understand here, because they all have the same location. Okay, so the location that B is assigned change every time we run the program. That is at runtime. That does not matter for us. The thing that matters for us is P2, which are both pointing to the address of B, is basically the same. All these three values are the same. Okay, all right. So when I dereference this double pointer, okay, I will get the address which is stored in P, because when you dereference a single pointer, you get the value which is stored at A. Okay, when you dereference a double pointer, you get the address of the location which P is storing. So dereferencing a double pointer, okay, pointer of a pointer, okay, it gives the address, the memory address which the pointer is storing. Okay, so when I say, okay, mem address in P is basically dereferencing P4, give me the value in P4. Okay, so you can relate this now. When we say this, it means give me the value which this pointer is pointing to. Okay, so P is pointing to B, so you get the value of B. Now P4 is pointing to P, so you get the value in P, which is basically an address. Okay, so when you dereference P4, you get the address in P. So the last four outputs should be the same. Okay, you see address in P is dereferencing this double pointer. Okay, address of P4, okay, value in P4 will basically be the address where P is being stored, which is ADDR4. Okay, that would be a different value. So value in P4, okay, value in P4, which is the address of P, okay, so that would be a different value. Okay, so these four values will be the same. This is going to be a different value. Okay, and we can have pointer of a pointer in doubles, in structs, in others as well. Okay, and finally, if you want to get the value which is stored in the location which P is storing, so you say value value at the address that P stores. This, no, yeah, value at the address that P stores is simply this. P stores %d. P stores an integer, right? P stores an integer, right? P stores an integer. Okay, so you can do this, or you can do double star P4. Okay, because this single star P4 means memory address in P, double star P4 means this thing. Okay, that is, give me the value which is stored at this particular location, which is basically the value which P is pointing to, which is B. Okay, so B came out to be 50, so this will also be 50. Okay, all right, so you can do this, or you can do this. Okay, so the value at that the P stores is going to be 50, and we will see we get 50. Okay, if I change the value of 50 before B before printing this, make it 100, it will now, the last value, the last output will be 100. Okay, because I changed the value of B to 100. So again, when you say star P4, it means you are dereferencing this pointer. So you want to get the value which is stored at this location, which is address of B. Okay, when you do this, then it basically means you are saying dereference me this. Okay, that is, dereference me the value which I get here, which is dereferencing address of B, which is getting the value of B. Okay, all right. So this is very basic starter thing about pointers. And one last thing is pointers of structs. Okay, so we have structs in C. So if I have struct a point, okay, so int x, int y, okay, right, that's how we declare a struct. And if I say, okay, pointers to structs, okay, so we use these stars asterisks to create pointers for these corresponding primitive types int, cal float, okay, and then we use dereferencing, okay, to assess the values or to change the values. So you can think of this in terms of the fact that when this comes on the right hand side, then we are dereferencing. That is, if I say int c is value at p, okay, then we give me whatever the value p is pointing to and store it in c. Or you can say star p is say 90. It means whichever value p is pointing to now stores 90. Okay, so don't get confused when you see star p on the right hand side or on the left hand side. When it is on the right hand side, we are assessing the value, we are not changing it. When it is on the left hand side, we are actually changing the value. Okay, we are saying set this value to 90. It means we are get me this value. Okay, don't get confused here. So let me print this value so that you don't get confused. So we have c %d, which is c, and then value at p is 90. So p is value at the p stores is single star p. Okay, double star p for the same thing. So you should get 90. You should get 190. Okay, so because b changed to 100, p is pointing to the location of b, c stores the value which is pointed by p, which is 90, which is basically b. So you get 90 and 190. Okay, right. So when c stores the value at p, p was storing 100. Okay, so c has become 100. When you set the value, you are setting the value which is pointed to by p to 90, then p is storing the value 90. So if I print b again, it will be 90. Okay, if you get confused, okay, just look at this diagram. Okay, so what I did in the final step was I created another variable. So if my memory extends, I created another variable c in main, okay, that stored the value pointed to by p. P points to this location, which now stores b stores 100, right? Okay, b stores 100. So this now changed to 100. It was 30, then it was 50, then 100. So now c stores the value pointed by p, which is 100. Okay, then I say value which is pointed to by p is 90, then becomes 90. So it was 30, 50, 100, 90. So b was 30, 30, 50, then 90, okay, then 100, and then 90. Okay, let me just print this again, b here again. Okay, so just follow the values of b and you will understand. Okay, so b started at 30. Okay, b started at 30, then b became 50, then b became 50, then b became 100, then b became 100, and then b became 90. Okay, so just follow these and look at this diagram. It will help you out. Okay, so this is your basic explanation on pointers, and I think I'll do pointers to structs in a separate video because it is already too long, right? Don't want to make this video way too long, otherwise it gets very boring and you kind of lose the understanding, the track. Okay, so this was just basically about pointers. Think of, again summarizing, think of pointers as variables that hold a value, and the value that hold is basically address of a memory location. Pointer store addresses. All right, for integer pointer you say int, you add a star, you give a variable name. So just as a is capable of holding an integer pointer is capable of holding an address where an integer is stored. Okay, similarly for a like double, d1 stores a floating point value. A double pointer is capable of storing an address where a double value is stored. Okay, we also saw pointer of a pointer. Okay, we saw dereferencing a pointer. Okay, and we also saw if star p is on the left hand side, okay, we are actually changing its value. When star p is on the right hand side, we are actually assessing its value. All right, okay, and go through this diagram. Remember these phrases. Okay, memory location, address of a location, what does it mean by reference, dereferencing. Okay, all right, what does it mean by saying it is a pointer to this variable. Okay, okay, so I hope you like this video and this was helpful. In the next one, we move to pointers to structs.